everyone, welcome back to another lesson. Today's learning goal is I can graph quadratic functions on the coordinate plane and identify key features. Today we're going to talk about a very key feature called the axis of symmetry. Okay, so let's go ahead and get started. Similar to the axis of to a line of symmetry, parabolas represent in quadratics have an axis of symmetry. Okay, the vertical line that passes through the vertex is called the axis of symmetry, and the reason it's called that is because you can see that on both sides of this imaginary line, it is the same thing. So, just kind of like how a face down the middle, same on both sides. So this is called an axis of symmetry, and it goes through the vertex. Each point on the parabola will have a point with the same y value and the same distance from the y-axis, or the axis of symmetry. Think of these points as mirror images. Okay, so this point over here has a corresponding point over here. This point over here has a corresponding point over here. Same thing with this point, this point. Okay, so every single point on one side will have a corresponding point to the other side. For each parabola below, identify the vertex, then draw a dashed line to represent the axis of symmetry and write the equation for the line. So here we have a vertex that is right here, and that is -2, -7. And we have our vertex that, our line of symmetry, our axis of symmetry goes right here. And every point on here has an x value of -2, so therefore the equation for this axis of symmetry is x equals -2. Go ahead and try this one out on your own. What you should have found is that the axis of symmetry is x equals 1.5 and it has a vertex of 1.53. When a function is in standard form, that is ax squared plus bx plus c, we can use the formula to the right to find the axis of symmetry equation as well as the x value of the vertex. So, if we take -b over 2a, this is always going to be the x value for our vertex point. Okay, and so therefore it's also going to be where our axis of symmetry is going to be located. So, here, the graph of x squared plus 8 plus 8x plus 13 is shown to the right. And it asks us to complete A through D and check our answers. So here, this function has a value of 1, a B value of 8, and a C value of 13. It says to write our equation for the axis of symmetry. So our axis of symmetry, as we can see, is going to look like that. And that is going to be x equals -4. If it'll let me do that. X equals -4. All right, there we go. So, it says if -b over 2a is the x value of the vertex, how can this be used to find the y value of the vertex? So, let's first prove that. Okay. So, if we take that equation, -b over 2a, what we would have is -8 over 2 times 1. And we can see this gets us -4, so x would equal -4, just like how we see over here. Okay. This can be used to find the y value of the vertex by finding, if we find the x value, we can plug in -4 into our function right here to find the y value. So we substitute the value of x into the original function and solve for y. And so our vertex, therefore, if we do that, that would be -4 squared plus 8 times -4 plus 13. Oops. That's going to be 16 plus -32 plus 13. 16 plus -32 is -16 plus 13, which gets us -3. So our coordinates are going to be -3 or -4, -3. Here it says for each quadratic function, use -b over 2a to find the axis of symmetry equation and the vertex. So here, again, we're going to do negative b minus 2a. So b is negative 20, and 2a is going to be 2 times 2. So these negatives are going to cancel each other out, and so we're going to have is 20 over 4, which gets us 5. So our axis of symmetry is x equals 5, and we're going to plug that back into our equation. And if we do that, we find that 2 times 5 squared minus 20 times 5 plus 51 gets us 2 times 5 squared is going to be 50 minus 100 plus 51, and that all together gets us a value of 1. So our vertex is going to be 5, 1. Go ahead and try this one out on your own. What you should have found was that negative b over 2a is negative 4, so our axis of symmetry is x equals negative 4. And if we plug in negative 4 into the original function, we simplify that as shown right here, and we get that the y value is 8, so our vertex is negative 4, 8. Go ahead and try this one out on your own. If we use our formula negative b over 2a, we get that our axis of symmetry is x equals negative 0.5. 0.5, negative 0.5, and we plug that into our function. We find that the y value is negative 1, so our vertex is negative 0.5, comma, negative 1.